Assalamualaikum warahmatullahi wabarakatuh. Nama saya Syahrani aswar, representative of Group 8. Here I will explain learning to using Venn diagram in probability. In order to use Venn diagrams when talking about event, we must first understand the term mutually exclusive. Imagine there are two events, event A and event B. If they both cannot happen at the same time, then A and B are mutually exclusive. Example, organizing data using Venn diagram to find probabilities. Class contains 100 students. 70 of them like mathematics, 60 like physics, and 40 like both. If a student is chosen at random using a Venn diagram, find the probability that they like mathematics but not physics and like physics but not mathematics. We begin by drawing an empty Venn diagram to represent this example. In this diagram, math, and this circle of physics. We know that the overlapping region in Venn diagram represent the intersection of events. Like this. This is from math, and this is from physics, and this is like both math and physics. Why is the Venn diagrams like this? Because at the intersections is a combination of those who like mathematics and physics. Suppose this brown circle is worth 10. In the exam, we are given that 40 students belong the intersection. 40, this is 10, plus 10, 20, plus 10, 30, and plus 10, 40, and in the intersection is 40. We are given that 40 students belong to this intersection since they like both mathematics and physics. In the exam, we know that 70 of them like mathematics and 40 of them also like physics. This tells us that the number of students who likes mathematics only is 70 minus 40 equals 30, and we change the math is 30. 10 plus 10, 12 plus 10, 30. The total student who like mathematics is 10 plus 10, 12, 20 plus 10 is 30, plus 10 is 40, 50, 60, and 70. We can deduce that 60 minus 40 equals 20 students like physics only, and we change 20 in physics, and the total student who like physics is 10, 20, 30, 40, 50, and 60. Deletes the following Venn diagrams. We note that the number set of 10 outside is to ensure that the sum of the value within the Venn diagram is equal to 100. Since the class contains 100 students total, we are looking for the probability that a randomly chosen student will like mathematics but not physics. And this Venn diagram for students like mathematics but not physics. The gradient of the Venn diagram representing this event is red. Red for students like mathematics but not physics. From the Venn diagrams, we note that 30 students like mathematics but not physics. Since the student is randomly selected, we can obtain the probability of this event when dividing this number by the total number of students, which is 100. The probability that a randomly selected student like mathematics but not physics is 30 over 100 is the total student equals 0.3. Then the probability student will like mathematics but not physics is 0.3, and probability that randomly selected student like physics but not mathematics is 20 over 100 is student total equals 0.2. Then probability student like physics but not mathematics is 0.2. Maybe that just learning using Venn diagram in probability. If there is a word error, more or less sorry. Wassalamualaikum warahmatullahi wabarakatuh.